This is Robert Sapolsky, and you're listening to Father-Offspring Interviews.
Hi, folks. Happy December, and welcome back to Father-Offspring Interviews. Some quick housekeeping things.
Well, in sporting news, we were talking about how dentition can tell you something about a species diet, and a line of sharp incisors and big canines spells carnivore. And a number of people noted that's weird because baboons, 99% of their diet is vegetable matter. They hardly ever eat meat, yet the males have these gigantic canines. Isn't that what you would expect from a carnivore? And here's the explanation for that. In this picture, you could see two lion skulls. On the left, a female, male on the right, and you'll see they both have gigantic canines. This is the mark of carnivores. In contrast, here we've got a male baboon on the left and a female. And notice the male has gigantic canines and the female has like none. This is not the mark of a species that are mostly carnivorous. This is a mark of a species where males are using their canines to slash at each other. So that's it for News of the World.
All right, so for today's questions, we're going to start with one from Austin from Arizona. The brain and the endocrine system seem to be in constant conversation. Thoughts change hormones, hormones change thoughts. From your research, does one ever truly lead, or is it a loop?
So, chicken and egg, which part of a circle is more important? We've got this loop, as Austin describes. Brain influences hormone release, hormones influence brain function. Which is more important? Spoiler, they're both important, obviously, no surprise, but we will get to the details of that. Let's go into this. First, focusing on the effects of the brain on hormone release, and let's give an overview of that. The brain controls the release of all the interesting hormones. No one used to believe that. In 1900, people were first starting to figure out there's these glands in the body, your ovaries, your testes, your pancreas, your adrenals, and each one of them secreted some sort of chemical that would have an effect on the body. And people were beginning to learn these were hormones. The word didn't exist yet, but they were beginning to figure out there were these chemical messengers that came out of these glands at various places in the body, which had important physiological functions. And the first view of the field was the glands knew what they were doing. The glands were autonomous regulators, which is to say, your thyroid gland decided all on its own when to release thyroid hormone. Your adrenal glands decided when to release glucocorticoids, your ovaries, estrogen, and so on. They were independent. They were, each one of them, autonomous. Nothing else was important. And this mistake gave rise to one of the truly nutty fads in the history of endocrinology. There were ideas going on at the time, which was that in males, flagging male vitality over the course of aging was due to declining levels of testosterone. People were just beginning to figure out there's some chemical thing which became recognized as being testosterone. So levels of testosterone decline in males as they age, and this decline accounts for senescence. And all you had to do to prevent aging was to prevent the decline in testosterone. Turned out there were two problems with this. The first one was there's not actually that big of a drop in testosterone with aging in men. The other is it leaves out like 51% of the population. Nonetheless, these 100% male endocrinologists were speculating about this and came up with a totally obvious solution. If your testes, which are pooping out on you now that you're middle-aged, if your testes are autonomous, making their own decisions as to when they secrete testosterone, just like all these other peripheral glands, and they were beginning to run out of steam, just transplant somebody else's testes into you, some youngins. And this gave rise to this fad of transplanting testes from roosters or from monkeys into people. And you then had testes there secreting testosterone and taking care of everything and rejuvenating. And this was totally crazed. You were not allowed to say words like testicles at the time in the literature. So this was the monkey gland intervention. And this became a major business. Sanitariums in Switzerland, you would go there, expensive captains of industries, heads of state, documented at least one pope going there to be rejuvenated by getting some monkey testes transplanted into them, or eventually testicular extracts, steroids, the testosterone, and this was going to rejuvenate you. And this was wonderful. And testimonials from all of these people about how they felt like young bucks again. And it turned out there was a problem with that, which is if you remove somebody else's testes and transplant them into you, they're not going to know what they're doing any more than your testes know what they're doing. And moreover, when you were secreting testosterone from testes, they were now making a solution of this stuff out of water. Testosterone doesn't go into water. In other words, people were being implanted under their skin with bits of monkey testicles that did nothing, or they were being injected in their butt with saline, which rather than having any testosterone. But, you're spending a big chunk of money and having all these distressing things stuck into your rear end. There's a very powerful placebo effect going on, suggesting that you should feel rejuvenated by this. So this was the crowning achievement of the 1900 mistake, that these peripheral organs knew what they were doing. People then began to figure out they had no idea what they were doing. Because, for example, if you took out an adrenal gland and put it in a petri dish with some nice nutrient soup in there, it didn't make any sense. It secreted hormones at the wrong time, too much, too little. All of these peripheral glands, in fact, had no idea what they were doing. They were being controlled by something else. And it took some decades for people to figure out that the something else was the pituitary gland sitting at the base of your brain. It releases a whole array of hormones, people were learning, and they were figuring out there would be one particular pituitary hormone which would stimulate your thyroid gland to release thyroid hormone, another pituitary hormone that would get your adrenals to release glucocorticoids. The pituitary was in charge, and this gave rise to the soundbite that dominated everything back when I was a kid, sitting in the bathroom on the toilet reading Reader's Digest articles with titles like "The Pituitary, the Master Gland of the Body." The pituitary was actually running everything, until people began to figure out the pituitary had no idea what it was doing. Take out a pituitary, put in a petri dish, and it secretes crazy large amounts of these hormones and doesn't secrete any of the, and it just goes crazy. Oh, it doesn't know what it's doing either. And by the 1950s, somebody came up with this completely out in left field idea that the brain was controlling hormone release. The brain was the master gland. The brain released hormones from the base of the brain to the hypothalamus, which traveled an incy bit down to the pituitary and told the pituitary to secrete this or that hormone. The brain was in charge. This was put forth at the time by a very prestigious endocrinologist who was basically laughed out of the business, Jeffrey Harris, for the simple reason that brains aren't glands. Brains don't secrete hormones. This seemed so embarrassing and undignified for someone to suggest that the brain secreted hormones. Nonetheless, he made the suggestion. Almost everyone ignored him, but two scientists decided at this point to go and start looking for these imaginary brain hormones. The notion being that the brain, the hypothalamus, some neurons in there would secrete a hormone which caused the pituitary to secrete a particular hormone, which caused a peripheral gland to do its thing. And then a different hormone coming out of the brain would do its thing to the pituitary and so on. And we had this brain pituitary peripheral gland axis, except nobody believed it, except for these two guys who decided they were going to find these hypothalamic hormones that no one believed in. One of them was named Roger Guillemin, the other Andrew Shalley. Both have died in the last few years. Guillemin was 100. Shalley was in his late 90s. This was the 1950s. They started off working together as postdocs in the lab of Hans Selye, who's the godfather of stress research. And nobody knows what happened. One night, one of them made a snide comment about the other one's hairdo. Whatever, they had a break. They had a rivalry that suddenly formed. They each went their separate ways. Guillemin to the Salk Institute, Shalley to Tulane University, and they set up in competition with each other to try to find in the base of hypothalami these hormones that nobody believed existed. And it was a staggering scale of work that they had to go through. And it took them close to 2 decades to get the very first hormone. Who got there first? You say breathlessly. Over the course of, I think, a 17-year race, they got their papers submitted describing the first hypothalamic hormone and its structure 1 week apart from each other. And it's not clear which one counts as having gotten their paper in first. So this was this landmark, amazing observation. And these guys got their Nobel Prizes for this. And this was the first of a whole array of hormones coming out of the hypothalamus. So thus we have, going back to Austin's question, this is the nuts and bolts of the first half. The brain is able to regulate the pituitary with a whole bunch of different brain hypothalamic hormones. The pituitary then regulates peripheral glands with a whole bunch of different pituitary hormones. And as such, the brain is the master gland, and people have come to terms with this. So just to get a sense of some of the really remarkable ways in which the brain can regulate hormone release, here's one example. You have a woman or a female rat who has just given birth, and they smell their child for the first time. Olfactory information, little pheromone things floating from the baby in the air up their nose, which stimulates the olfactory part of the brain, which stimulates certain neurons in the hypothalamus. And as a result, you secrete the hormone oxytocin, which makes you feel in love with the baby and causes milk letdown and all that. An odor. You smell your newborn, and suddenly you're secreting a different hormone by way of the brain regulating this whole pathway. Another example, this one I love, there's a literature showing that in athletic competitions with men who were winners tend to have an increase in their testosterone secretion afterward, losers a decrease. This is a trend. There's a lot of studies where people are not able to show that, and somebody figured out there's something much more interesting going on. This, I believe, was a marathon, and what they did beforehand was ask the participants, how fast do you think you are going to run this marathon? What are you hoping to pull off today? And if you looked at, did they wind up being number 1 or 2 or 3 or 4, that was not predictive. If they bettered their predicted time, up went testosterone. If they did much worse than anticipated, down went testosterone. It was not your place in the finish. It was your own assessment as to what that meant for you. So the brain figuring that out and deciding whether or not to tell the testes to secrete testosterone. Finally, classic story in pediatric endocrinology. This was after World War II. There was 2 orphanages. I think they were in Belgium in the aftermath, and each one was full of orphan babies and toddlers, and each one had a woman in charge. And it turned out, straight out of like a Grimm's fairy tale, one of these two women was warm and nurturant and held the kids 24/7 and sang to them. And the other one was cold, hardly had any contact with the kids at all. Eventually, they were observed. This was actually documented. And what the researchers found was the kids in the orphanage with the warm, nurturant woman running the place were growing faster than the kids in the other orphanage and had higher levels of growth hormone in response to this whole cascade. Okay, maybe it's got something to do with the women. Maybe it has to do with the latitude or the price of bananas at the nearest market to each, whatever. And what made it the perfect study was then there was some bureaucratic hiccup and the two women were transferred to the other orphanages, and suddenly the growth rates reversed. Think about that. The extent to which these toddlers were feeling safe and loved in the world was translating into their brain, regulating how much they were growing. So this gives us a sense, the first half of the brain regulating hormonal release, and we will get to the second half.
Switching gears here, Michael from Germany/Spain says, as a musician, composer, and musicologist, I wonder what no free will means for the creative human output.
Wonderful. This generates a profound pair of questions on very different levels. First, on the larger level, if there's no free will, one has to begin to ask, Michael, how did you wind up being the sort of person who would become a musician? And when looking at the steps, the preceding steps by which the present was determined by what came before and what came before and so on, there was no free will involved, and you could just as easily have wound up being a day trader or a warlord or a sculptor or something. And to the extent that you have one instrument that you specialize in, it could have been, you could have wound up with some other instrument. You could have been a sackbut player or a theremin or a didgeridoo or some such thing. So how did you become who you are, big picture, in terms of evaluating what are the consequences if there's no free will? But there's an equally profound question on a more local level, which is what do we make of creativity in a world in which there's no free will, in a world in which we're biological machines, where all we are is the sum of the biology over which we had no control and its interactions with environment over which we had no control. Is it ever possible to come up with something that is freely creative? So if we're thinking of free will as being a circumstance in which you can take an action that is completely independent of all of its history, the equivalent now would be with creativity, where you have produced a work of art that is completely independent of all the art that has come before. And this has actually been something people have spent a lot of time debating in musicology. And the general sense is no, there's nothing that is blindingly creative that came out of nowhere. Because no matter what you do, you were a person of your time and place and your culture. No matter what you do, there's the timbre of the instruments that you were familiar with from your time. You were familiar with all the music you've heard before. So in that kind of context, what is musical creativity? What's any form of artistic? It's not coming from out of nowhere. Some of the time, it's doing something random. Some of the time, it's doing a novel combination of things. Some of the time, it's doing a novel translation of what multiple parts of a system mean. Randomness, the Dadaists early in the 20th century had this great quote where they characterize something being as beautiful as the chance meeting on an operating table of a sewing machine and an umbrella. Randomness is not free will. Randomness is not absence of free will. That's a beast all on its own. But what about the notion of creativity not being free, but instead a novel combination of pre-existing pieces. Great example of that. Igor Stravinsky, Rite of Spring, revolutionary piece of music, coming up with music of a type that no one had ever heard in a concert hall before. And it turned out he was quoting all sorts of folk music. The opening, famous opening of it, is a modification of a Lithuanian folk song. He used elements of other Slavic folk songs, Central Asian ones. But look at how creative when you listen to it. The melodies are chopped up and atomized and all sorts of strange combinations of them. And that was creativity that came from nowhere. That didn't come from nowhere. Stravinsky very explicitly said he was trying to do a music equivalent of Cubism. He was translating Cubism into sound. So nothing purely creative there. By the way, great urban myth. Every child on earth is taught that when the Rite of Spring was premiered in Paris in 1912, people were so outraged by the dissonances that there was a riot. People fought with each other, fisticuffs. The police had to come in and drag people away. And this is monumental. This is the piece of music that started the 20th century revolution, and people rioted. They were so caught off guard by its radicalism. And it turns out the riot never actually happened. Some people kind of yelled at each other. There was no physical contact. The police were not called in. So where did this myth come from? About 15 years later, when there was going to be the first performance of Rite of Spring in the United States, the conductor, trying to drum up sort of excitement about this radical piece coming to America, came up with this story saying, when it was first performed in Paris, there was a massive riot and people killed each other and cannibalized each other, and come see this scandalous event. And it just took off from there. So there actually was not a riot after Rite of Spring was premiered. Another example, here we have translating not so much the music, but the emotional context of it. And this involves a group that I love called Daniel Kahn and the Painted Bird. And it's very hard to describe them. They describe themselves as being alienist klezmer musicians. But in one of their songs, they are singing, playing something that is a traditional old Yiddish mourning dirge and tragedy and all of that. And as you go through the song and listen to the lyrics, it is a dirge in Yiddish for the Palestinians. Whoa, who would have put those two pieces together? And that's part of the creativity of that. More examples. Charles Ives, composer, probably America's greatest composer. I got obsessed with him in college because I decided I wanted to pretend to be a New Englander. Charles Ives, just dizzyingly creative. And the whole point was he was an insurance executive. He was just composing in his closet on the weekends kind of thing. He was completely out of touch with all the modernism sweeping through Europe. And yet, absent all these influences, he came up with music with startling polytonality, two different keys being played at once, with polyrhythms, different instruments playing different rhythmic patterns. Oh my God, pure creativity. It wasn't pure creativity, because it turns out where that came from was when Ives was a kid in Danbury, Connecticut, shortly after the Civil War. There was a Civil War commemoration parade, and two marching bands came towards the town square from different directions, and they were playing in different keys and different rhythms. And he heard that, and he thought this was the greatest thing he could ever imagine. So the roots of that, a novel setting for that in a concert hall rather than a random active polytonality and polyrhythmicity. Another example really gets at the core of this. Okay, so suppose you say, my parents were the greatest and all I want to be is exactly like them. This suggests a marked absence of free will. You are entirely shaped by that. Suppose instead you say, my parents were nightmares. I want to be different from them in every possible way. You are just as unfree if that's the case. You are just as constrained either by following a pattern or constrained to avoid following a pattern. And you see an example of this with the 12-tone serialist composers, Arnold Schoenberg, who wanted to break apart dead white male European tonality. And what they did was, from a C up to the next C, there's 12 notes in between. And they constructed tone rows where you played each of the 12 notes and you couldn't repeat any of them, and you didn't do them consecutively. And this was to completely break apart the tonality. Take that. All of our ancestral parent composers were doing something totally different from what you ever did. But suppose this process of coming up with these tone rows, of having a sequence, suppose just by chance, suddenly out pops a major chord. Bum, bum, bum. And oh my God. And what do? You immediately get rid of it. Schoenberg expunged it. That was not free will. That was showing the same absence of free will as if he was trying to sound exactly like Beethoven. And you see this at its most extreme with someone like John Cage, famous, notorious piece of music, 433, where what Cage was trying to do was say, I am free of every musical influence that came before. And what 433 is the performer, the pianist, sits down at the piano and does nothing for 4 minutes and 33 seconds, and then gets up and bows and walks off the stage. Oh my God, the radicalism of this. And you can see all this was the same unfree banishing of every musical precedent beforehand. So I think what we see with creativity is you can get thoroughly unexpected, wonderful, novel combinations, novel emotional meanings of things, but it's not a way to sneak in free will through the back door.
Okay, so we're now going to return to the topic of hormones posed by Austin. Having covered the effects of the brain on hormone secretion, we'll now focus on the effects of hormones on brain function.
Good. So completing this circle, we now know the brain is the master gland, all of that. And what people had to spend almost as much time on was figuring out, accepting that hormones, these things that cause you to grow body hair in unlikely places or make your pancreas do something, hormones affected every aspect of what your brain does. Now, for that to be the case, the most common thing is hormones in your circulation, in addition to getting to every other cell in your body and doing hormonal stuff to your big toe, able to get into the brain past the famed blood-brain barrier and get to neurons and glial cells and the other types of cells you find in the brain. And a big revolution in the 70s was the discovery that there were receptors for these hormones in the brain, for different hormones and different levels of these receptors for different brain regions. I did my doctorate with a guy named Bruce McEwen at Rockefeller University, who was the first one to demonstrate glucocorticoid receptors in the brain. So this was totally exciting. Hormones can come in and they could affect the way the brain works. This was totally boring, people thought initially. Okay, let's think about how toilets work. So you got your tank there and you flush and you now have water coming in and there's a flotation device. And what it's doing in effect is measuring what the level of water is in the tank. As it rises, the flotation device comes up, and when it gets high enough, it is attached to a shutoff valve. We have a negative feedback system. So we've got, say, your brain releases some hormone that makes your pituitary release some hormone that makes your thyroid gland release some hormone. Your brain wants to know, is it the amount in the bloodstream now that it wanted in the first place? Some of the thyroid hormone gets back into the brain, and there are thyroid hormone receptors, and it works like a thermostat. It works like a toilet bowl tank at that point. There's a set point. This is how much I want in the circulation now. Ooh, if we're not there yet, let's pump out some more of the stuff. If we've reached it or higher, shut it off. All hormones we're doing in the brain was sort of closing this regulatory loop with negative feedback regulation. That's what people thought. But then they began to see hormones affecting the most unlikely parts of the brain, your cortex, your olfactory system, hormones going all over the place, and hormones doing everything conceivable to neurons, causing some of them to open up ion channels, others to do the opposite, causing neurons to grow new processes or retract them, triggering the birth of new neurons in some cases, killing neurons and other hormones getting into the brain, able to basically impact every aspect of brain function. So now let's get a feeling for some of the examples of circulating hormones having effects on the brain. First example, glucocorticoids get into the brain, and stress, fear, anxiety, lots of glucocorticoid receptors in the limbic system, the part of the brain related to emotion, some other hot spots in the brain, the frontal cortex. What do glucocorticoids do in somebody's brain? Among other things, they cause people to become averse to risk taking. They're less likely to gamble on something. They feel less confidence in their decisions. Whoa, how you assess the likelihood of like pig iron stocks going up or going down is being in part regulating by this hormone from your adrenal glands down there getting into your brain. So hormones regulating the brain. Another example, oxytocin. We heard a bit about it. Oxytocin gets into the brain, and what it does is it makes you more generous. It makes you more trusting. It makes you look at a face that has a neutral expression, and you become more likely to decide it's a friendly expression. You become more emotionally expressive. Totally amazing. Turns out to be an interesting footnote to that. Oxytocin only has these effects on how you interact with people who count as an us. It makes you more generous, more pro-social to in-group members. It makes you jerky and antisocial to out-group members. Again, this is a hormone in your circulation getting into your brain and causing you to have completely different socio-political opinions than you would otherwise, to have different views about us's and them's. Third example, and this is one of my favorites, what's the inevitable sex difference that people always think is there in solid granitic clarity, which is that males are better at math than females? And study after study and all over Earth, and turns out that's not really quite the case. And there's some really interesting ways in which it's not the case. But okay, so now you have studies by people who believe that males are indeed, on the average, better at math than females, and that it's driven by testosterone. Testosterone doing stuff to the fetal cortex, to parts of the cortex that do computational stuff, and that explains everything. And studies looking at if you inject people with testosterone, do they get better at math? Simple question there. And a whole bunch of studies have looked at this, and the answer is no, it doesn't make people better at math. It does something better. You, some male volunteer who gets shot up with testosterone, you don't get better at math, but you decide you did better on the math exam than you actually did. Testosterone doesn't enhance mathematical abilities. It makes people cocky and overconfident. So getting a sense of the subtleties going on there. So Which is more important? Austin asks, is it this piece or is it this piece? And you know exactly what the answer is you can't choose because they're so interactive and synergistic and interdisciplinary. And yeah, they're both incredibly important and they both influence each other to such an extent that you can't even validly say, ah, this was a neurobiological event. This was an endocrine event, totally intertwined.
That's it for episode 90. I'm Offspring Sapolsky, and thanks for your continued support of Science and the Beard.